Hello friends, in our mathematics class today, we want to show how to prove cosine rule. So given this triangle, we have triangle ABC in which AD is perpendicular to BC and the distance between B and C is A, the distance between D and C is X. So the distance between B and D will be A minus X, alright? So let's apply Pythagoras theorem to triangle ABD first. So we can now say C squared is equals to A minus X squared plus H squared. Alright, if you expand this one, it will give you C squared to be equals to A squared minus 2AX plus X squared plus H squared, which is the same thing as A squared plus H squared minus 2A x plus x squared. Let's call this equation 1. Let's come to triangle ACD and do the same thing using Pythagoras theorem. So we are going to have it as b squared to be equals to h squared plus x squared. Alright? So if we have it that way, you can see that my equation 1, c squared, can be the same thing as x squared plus a squared plus h squared minus 2ax. So c squared is the same thing as x squared plus h squared plus a squared minus 2ax. This is the same thing as b squared. So c squared can now be written as b squared plus a squared minus 2ax. Alright, so having this way, I can now come to this angle C and say cos C is the same thing as adjacent over hypotenuse, my adjacent over B. Alright? So from there, my x is the same thing as B, B cos C. B cos C. So if you call this equation 2, if you bring it up, it will now be C squared is equals to B squared plus a squared minus 2ax. This x here is the same thing as, let's call this equation 3. Don't mind the way I write it though. So we now have equation 1, equation 2, equation 3. So x is the same thing as b cos c. From this, we now have c squared to be equals to b squared plus a squared minus 2a. This x is now b cos c. It can be written better as c squared is equals to a squared plus b squared minus 2ab cos c. This is the cosine rule. Thank you.